Please write yes in your chat box. Thank you. Thank you, Abhishek. Go ahead. Let me see. Ankita, that's Sakshi. Very good. Thank you. Thank you very much. Great, 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 great. Nice. So nice of you. Thank you. Thank you. Great. Okay. So let me share my screen with you. And the second analysis uh, where we want to see a significance difference. So first analysis was based on categorical variable, where we check association between two or more than two variables. Now today we're gonna check a significance difference, a significance difference. And when we talk about significance difference, actually we are reflecting on t-test. So before I proceed further, I show you some data. I have 3 files. And beside that, I will show you how we can do it on SPSS. You can note down some commands, or I will share this PPT with you. And then I will give you an AI which can assist you and can give you the output. Okay. But here again, input you must know, input in terms of data. Second input in terms of which test and why this test only. Why not other test? And when we use this test, what is the purpose of using this particular test? Is it to go for finding out association or to know about significance difference between two variables? So what are the basic prerequisite? What are the requirements to perform a test that we're gonna discuss today with all of you, right? So I can see right now 30 participants, and now I'm going to share my slide with all of you. Okay, fine. So here we go. I hope this is visible to all, everybody. Is this visible, madam?
Yes, sir, it's visible.
Oh, fine, thank you. So first, when we talk about data, we need to describe data. The first step in research analysis is describing your numerical data. Now, as we discussed yesterday, beside the numerical value, beside the continuous variable, we have categorical variable also, right? For that, we use frequency. Frequency gives the number of observation or cases that fall into each group or category, right? So this is basically occurrence, for example, male and female. But before that, let me show you my data. Student data 1, I show you this data first. Just give me 1 minute. Okay. This is the data, ladies and gentlemen. So first, student ID. Which section are they in? Gender, location, entrance exam score, faculty, right? Percentage, let me show you this also. Percentage in first year, percentage in second year, okay, something like that. And incidence of, and one more, hours spent, okay, hours spent on reading. Incidence of absence, percentage first year, percentage of student in second year, at the time of entrance, what was their score, faculty, 1, 2, 3. Now see here, are we going to collect data in terms of 1, 2, 3, 0, 1? When we talk about categorical variable, generally not. We say that male or female, which city are you from, right? So we need to categorize our data in terms of 0, 1, 1, 2, 3. For example, faculty. What is faculty for you? What is faculty? Is it numerical or it is categorical? So 3 faculty we have: art, science, and commerce. Tell me in your chat box. Let me see. Come back to you. Where are you? Yes. Just a minute. You are here. Yes. How to describe the faculty here? Categorical. Thank you, Dr. Sakshi. Categorical. Right. So it's a 1, 2, 3. Again, a frequency, right? So how many variables we have? Just check. Let us check how many variables we have, which are basically a categorical. So first, student ID, just forget about that. Then the second is section, right? How many sections we have? One. Students are in, okay, all are in one section, so it's not important. Then we have gender, male and female, location, 0, 1, right? Entrances. So how many? So forget about student ID and section. So first gender, second location, third faculty, right? So this is 3 are categorical variables. Others are, please tell me in your chat box. Others are, what kind of data is it? Other variables in Excel sheet were, please write in your chat box, everybody. Any response in your chat box? What we call them? Numerical or continuous. Thank you. Continuous or numerical value. Okay. So here we are. So first, we need to describe our data. So you know student data 1, you have seen the student data 1 file. And let me go ahead with this. Okay. Now, what you need to do, how to describe your information which you have collected through Google form or a questionnaire. So gender, male and female. So we gave 0 and 1. Location, you are local or commuters, 0, 1. Faculty, arts, commerce, science, 1, 2, 3. And finally, the observation, right? Other observation, the entrance exam score, first year marks, second year marks, reading hours, absence, right? So this is what the numerical value we have. So first we must know what kind of data we have, and are we able to describe what is the purpose of describing this data? To make our software understand. If you write male and female, it will not understand. So you need to code your data. It's a kind of coding of your data and tell the computer or the software, maybe SPSS or maybe PSPP. PSPP is a similar kind of a software which is like a SPSS. SPSS is a costly one, but PSPP is free, right? You can check that. PSPP, right? Will have similar kind of a function. So we are describing our data first and then go for analyze. So this is a command in SPSS, right? Analyze descriptive statistics and frequency. And so you're going to get frequency of male and female. How many? So total is 60 respondent and 31 respondents are male and 29 are female. Let me show you my data. Okay, here is the data. So total data is, as I said, I told you, it's around 60. I mean, right? It's around 60. How many male and how many female? Which other variable I can take for frequency? Tell me in your chat box, everybody. Which other variable can I take as frequency? Please write in your chat box. Beside gender, which other variable I can take for frequency? Okay, location, very good, very nice. Any other? Any other? Faculty. Thank you, Dr. Sakshi. Thank you very much. Okay, great. So let's move further step by step. So first we need to describe, then go for frequency. And let me continue here with this. Okay, finally, one more thing. Now, after this categorical, we need to check the numerical data also, right? So we will be using, we call it descriptive statistics, right? What is the role of this? First important thing is we should not have categorical variable. We should have interval or ratio scale. Please note down. And what we can calculate out of this? Central tendency, mean median mode, measure of dispersion, and measure of skewness and kurtosis, right? This says something at the last. Please note down, use only continuous data. Use only continuous data. So first, you need to describe your categorical variable. Then second, talk about your numerical data. And numerical data, first step is, in numerical data, first step is uh, descriptive statistics. So we are describing our data. First describing your categorical and then describing your continuous variable. Okay, for this, here we have SPSS, again analyze, descriptive statistics and descriptives. So select variable, which variable we will select? So here we can select three variables: marks, score in entrance exam, numerical value; percentage of marks score in the first year, numerical value; percentage of marks score in the second year, numerical value. What we can find out of this? Minimum, maximum, range, standard deviation, variance, skewness, kurtosis, and finally the command is again repeated here, right? So this is a basics, and now we'll enter into, as I mentioned, you can go for this plot also, right? But before that, when we talk about plotting your data, what we need to do, we need to check your data. Is it normal, right? Normally distributed, right? So for that, please pay attention. Which variable can I select for checking the normality? Continuous or categorical? To check the data normalcy, normality of the data, should I take categorical variable or a continuous variable? Or both? Tell me in chat box, everybody. Categorical variable, continuous or both? You can reflect in your chat box. Yes. Tell me, please, quick response, everybody. I think both. Okay, both. Is it both? Can we check the normalcy of gender, 0 and 1? Will it be useful? Can I check the normalcy of that normality of data, normal curve, normal distribution curve of male, female? Okay, okay, thank you. Continuous. Thank you very much. Thank you very much. So numerical value, and here I have taken an example. Now you can see which example? Percentage of mass score in the first year, right? So please pay attention. We are going step by step. So explore function in SPSS will give you this. Select percentage of mass score in the first year, right? Now you can plot it, whether it's a normal or not. Now, when you talk, see, what would be the output when you run and what would be the interpretation? So as per the thumb rule, these are few things. You will get variance, median, arithmetic mean, confidence interval, right? So this is for what? It's not for gender. It's not for faculty, right? It is for continuous variable. And here continuous variable is percentage of mass score in the first year, ladies and gentlemen. So you're going to get this result, right? And then when you get this result, you can write this, that arithmetic mean is equal to 59.08. Standard error is 0.876, right? So this all information we can write on the basis of outcome, right? Minimum, maximum, range, interquartile, everything you're gonna get with one function. That is the beauty, right? So one output, actually we are describing our data. First categorical data and then continuous data. Now, very important, is your data normal? Is your data normal? So we have this test here. You can see whether your data is normal. Tell me, our data is normal or not? Is our data normal or not in this case? I am not going ahead. On the basis of this significance level p-value, what do you think? Data is normal or not? So two tests, Shapiro, and here you see Paul-Margul. Two tests you do with. So I'm telling you the basic first, describing, categorical and continuous, then check the normality of continuous data. This is the prerequisite before you go for any test, right? So now my question is, what do you think? Our data is normal or not? Let me come back to you. Anchan say no. Okay, great. What about others? Is data normal or not on the basis of outcome you have seen? So I'm telling you which tool, what we should do, right? So Anchal say, no, it's not normal. What about others? What about others? Please, can you respond? Is our data normal? No, right? But it is less than 0.05, right? It is less than 0.05. Don't you think it's a normal? What is the thumb rule in general when we test the hypothesis? We say it should be less than 0.05, right? Reject the null. Okay, so now please pay attention, everyone. So this is the test, right? And how we go proceed further, let me show you this something. Shapiro, what is the purpose? Check whether a sample comes from a normally distributed population or not, right? And the hypothesis that are normally distributed, alternative that are not normally distributed. So here you see, if p-value is less than 0.05, reject that are not normal. If p-value is more than 0.05, fail to reject that are approximately normal. So please, it's an important caveat here, ladies and gentlemen, right? It's very, very important here. Check this. Okay. And just forget about this. We go ahead. Okay. Generally, what we do in our research, let me go to directly to research. So this is basically, come to research, right? We start with t-test. As I said, before I go actually describing this with example, numerical example, I describe it with one story, right? T-test to find out significance difference. You remember in last class, we had a kind of discussion on Mahindra and Mahindra Thar and Jimny, right? What Mahindra and Mahindra did, as far as Thar Rocks is concerned, their claim was that now their mileage of Thar Rocks would be more than 12, right? So this kind of assumption, this kind of claim comes under one sample. What is the sample? 12. Less than or more than 12, right? One sample, right? So what are the assumption of this test? So what is the basic concept of the test? We check the significance difference between two variable. But here, before I go, I say that my value is 12. Mileage is 12. I want to see whether it's equal to 12 or different from 12. Okay. So first, one sample t-test. Here, different assumptions, random sampling, single population. So here, please pay attention. what is the population here? In our case, mileage, right? And we check the normality. Data must be continuous and it should not depend on any other data. So mileage is not dependent on any other data. We are not describing other data. So our mileage is independent. Okay. So I'm taking example from maybe a same data I had, percentage of mass score in second year by the student, right? Now pay attention, everybody. What is the hypothesis? What is the claim? The claim is the average percentage of mass score in second year by the student is different from first year average of 75. Is it the right example I have mentioned here? Tell me. Is it the right example? Tell me. Of one sample t-test? Yes or no? Tell me quick, everybody. Is it the right example of simple t-test? No response. Reflect in your chat box, everybody. Is it the right? Okay, I show you again. Just a minute. This is once, is it right example of one sample t-test? Let me make it big. Tell me, this is the hypothesis. Is it the right kind of hypothesis I have written here? Let me come back to you and see your response. No. Why no? Because here I am comparing two, first year and second year. But in one sample t-test, I mentioned one variable, right, in assumption, and I say that it's a 12. And in case of marks, it's a 75. So assume 75. And in our case of mileage, 12. So I will say my claim would be that mileage of Thar is more than 12, right? And what would be the complementary? Or we can say, yes, tell me. Anyone who can help me out? Can we say it's a more than, and what would be complementary? Less than or equal to. Are you with me, everybody? Right? Yes, yes. Thank you. Thank you very much. Thank you very much. Okay, great. So this is, knowingly I have written here this. So let me come to next slide and show you what should it be. Okay, here percentage of mark in second year. So I will take any particular one variable. So in our case, I said that test value is 75. Test value is 75 in case of marks and 12 in case of mileage of Thar. Okay, everybody? Okay. So one sample test table, it will give you n number of observation, mean, standard deviation, standard error. This it will give you. Plus one sample table show there is a significant difference between hypothesis mean and sample mean. Because here what I'm going to do actually in this, let me give you right kind of example. Let me come back to you. Then you will be able to understand. Okay. What was the claim of the Mahindra and Mahindra for Thar? That mileage is more than 12. And suppose they produce 10,000 Thar. Now they need to certify this claim. But who will certify this claim? You yourself as an organization or government agency will certify you. So generally, Mahindra and Mahindra approach government organization, sir, this is our product, could you certify it? So government will say, okay, we'll certify, let us run your Thar for 1 lakh kilometer, and then we will see the mileage. If it mileage is more than 12, we will certify you. Then you can go and market your product. Right, everybody? Now the problem here is this, out of this 10,000 Thar rocks which Mahindra & Mahindra has produced, Do we need to run all 10,000 for 1 lakh kilometer to check the claim? Tell me in your chat box, everybody. Do I need to run all 10,000 Thar for 1 lakh kilometer to check the claim of no? So if I run all 1 lakh, oh sorry, 10,000, I mean, who will be buying my Thar? I have run it for 1 lakh kilometer. So Mahindra says, sir, randomly pick any 10 Thar, run them for 1 lakh kilometer, right? And then finalize that. Okay. So I give you Thar today, everybody. I don't know how many of you will be ready to ride Thar today for 1 lakh kilometer. And suppose I select 10 among you and give you one Thar today, and you run it for 1 lakh kilometer, right? So actually we are testing hypothesis with collection of data. So, and now we know the claim also, right? We know the claim. Claim is more than 12. And null hypothesis, we know it's a less than or equal to 12. I request Miss Ruchi, please run it for 1 lakh kilometer. Ruchi says, sir, my mileage, average mileage was. Sonali says, sir, my average was 11. Namita says that my average was, sir, 13. Preeti says that, sir, my mileage was 20. I don't know how she did. Did she drive? Juhi said her my mileage was 15. So how many observation? 10. So I have taken 10 responses from 10 people, those who have run Thar. Now, what I can do with this? I can find out the mean of these 10 observation. And what was the mean of population claimed by Mahindra and Mahindra? What was the claim of Mahindra and Mahindra? 12. Thank you very much. 12. Now, on the basis of 10 observation, I wish to find out the average, X bar. And mu, what is mu? 12 is the mu. And X bar is, I will calculate. Suppose my X bar is 10. So on the basis of 10 observation, when I calculate the mean comes 10. Who would be in trouble? Who is in trouble? Everything is okay in this case. Your claim, Mahindra and Mahindra claim is 12. But when government run your Thar, randomly select 10, the mean was 10. Do you think government will certify you? And in this case, who would be in trouble? Mahindra and Mahindra would be in trouble because they cannot market, they cannot sell their product. Yes. Now, Mahindra and Mahindra will say, sir, this would have been by chance. This could be by chance also, right? Take another 10 Thar and run them for 1 lakh kilometer. Now you tell me, everybody, do we collect data again? Suppose you have collected 300 data, sample size. Will you go and collect data again, 300? And then Mahindra will say, sir, in this case, second case, the average is 9. So what will Mahindra say? Sir, take 10 again and run them. Do we have this kind of approach in our research? No, ladies and gentlemen, no. We once collect data, and what we need to do, whatever mean we have, in our case it was 10, and we will say it is not by chance. And you conduct this study 100 times, the mean would be 10. So it is not by chance. So what we are doing actually in our research, please pay attention. Now the problem here is, how is it possible? How you can claim that you run this 100 times, similar kind of observation, your answer would be 10. How can I say this? Anyone? Unmute your mic, or you can give your reflection in your chat box. If you understand this concept, then all hypotheses you will be able to understand that, okay, this is going on. This is the concept of hypothesis testing. You want your result by chance, or you are sure? How much by chance you can think of, you can afford? Not sampling technique. Okay, no. It's not linked with sampling technique or sample size. Huh? Yes, we have to calculate standard deviation. Okay, no, it's not linked with standard deviation or confidence interval. How can I be sure that if I run it, do we run this test again and again 100 times? Collect data 100 times again and again? No, just once we have collected data of 10, and will be sure that this data, this mean is not by chance. Please pay attention, everybody. Please pay attention. This now, till now, whatever we have discussed, this is called descriptive statistics: mean, median, mode, standard deviation, this, and this. Now onwards, it is called inferential statistics. Now we are entering into inferential statistics. On the basis of one observation of 10 responses, we will infer that it would have been conducted 100 times. Result would have been same, and it is not by chance. How does it happen? So hypothesis testing is all about this concept, that you take one observation of 10 participants, and on the basis of 10, you will say you conducted 100 times, 10, 10, 10, 10, 10, 10, 10, 100 times, result would remain same, and it is not by chance. So your hypothesis is having this kind of basic concept. So your hypothesis run on the base of this kind of basic concept. Please pay attention, everybody. Write in your chat box, yes, if you are with me. How does it happen? If you want, I can show you that also, right? But conceptually, I hope you are understanding what I'm talking about. Once we collect data of 10, we are not going to collect it 100 times, but inferential statistics say that we conduct it. If you conduct it 100 times, you're going to get same result. It is not by chance, right? What happens actually? Our x bar is 10, mu is 12, x bar minus mu divided by standard deviation. This is the approach. In case if you conduct it 100 times, so standard deviation for one observation of 10, right? But in case of, ladies and gentlemen, if I wish to conduct it 100 times and I want to infer that same result will be there, in that case, instead of standard deviation, we use standard error. We use standard error, right? What is the concept? If you wish, we can discuss it later. But now I have given you a clue. I have given you a justification of testing a hypothesis, that on the basis of 300 observation, are you going to collect 300, 300, 300, 100 times? No. But your hypothesis say, if you would have conducted this 100 times, right? How much you were sure? 95% times I was sure you want to get same result, but 5 times by chance it could be. Okay. Are you with me, everybody? Now you're understanding what does 0.05 mean. 0.05 means less than that it could be by chance. What we want our confidence must be more than 95. It's not by chance. This 10 is not by chance. Okay. Are you okay? So this is the basic concept of hypothesis testing, that on the basis of 10 or 300 observation, we are not going to collect again and again these kind of observation. So here you see this one sample t-test. This is the outcome. How will you be interpreting it? Tell me. The output indicate that there is a significant difference in percentage of marks scored by the student between first year and second year. And what about our case, where it was 75? Will you reject hypothesis, null hypothesis, or you will not reject the null hypothesis? Tell me. Will you reject the null hypothesis or fail to reject the null hypothesis? when it is less than 0.05. Please give response in your chat box, everybody. Yes, yes, yes. Any response? Okay, okay, fine, Dr. Pratiksha. We reject the null hypothesis and we go with the claim that, what is the claim? In case of Mahindra, that your mileage is more than 12. And in case of student marks, it's right different from 75, more than 75, something that. Okay, thank you very much. So any doubt in basic concept of hypothesis testing? Tell me. So with this one sample t-test, I have clearly defined the concept of t-test. Anybody, any question up to this? Anyone, please tell me. You can write in your chat box, or you can raise your hand, or you can unmute your mic. Yes, ladies and gentlemen, tell me. Any doubt? So first t-test, one sample t-test. Okay. And I have defined yesterday, if in claim your it's a more than, it's a right tail. If it is a less than, it's a left tail. Right? If it is not equal, two tail. Okay, let me continue with my discussion. I know I am a bit slow, but now comes to second kind of t-test, which is known as paired t-test. Which is known as paired t-test. What happens, for example, we want to see your learning before this workshop and after this workshop. In this case, sample size remains same, right? The responses remain same, respondent remains same. So before and after we check the result, is there any significant difference between before this workshop happened and after the workshop? And what we are capturing? Your intelligence, your learning. So what is dependent variable? Learning or intelligence. So you can select one. So one variable, but factors would be before and after. Otherwise, if you see, the assumptions remain constant. Assumptions remain constant. Okay. So percentage of marks score in the first year and percentage of marks score in the second year. What do you think? Student will be same? Like this workshop before and after? Write in your chat box, yes or no. First year, second year student, will they be same or different? Please do write in your chat box. Let me see responses. Different. Why difference actually? Student in BCom honors first year, they go to second year, right? Same. Thank you. Thank you. Section A and section B, they would be different. They would be different. Okay. They would be different. So fine. So now you know what is paired and what are the assumption and percentage of marks of student in first year. When they go to second year, student will be same. So this is paired, same student. Okay. Okay, fine. Now, see, on the basis of our concept hypothesis, we want to check, is there any improvement between percentage of marks in the first year and in the second year? Is there any improvement? We want to check. And complementary to this, null would be no improvement. So null means no, I don't know anything, null. So let us see, is there any improvement or not, right? So which test we are using? Pair t-test. So here, analyze, compare means pair t-test. If you see in SPSS, this would be the command. Select two variables, percentage of marks score in first year, percentage of marks in second year, right? So this is, and you're gonna get the result also. Interpretation. First will remain same, the descriptive statistics. But the important would be the third table. Third here you can say the pair sample t-test gives the difference. I'm not reading it for you. Read it and tell me, should I reject the null hypothesis or not? Should I reject the null hypothesis or not? And your p-value is now come to you. Tell me, should I reject null hypothesis or not? Tell me in your chat box. Yes. Accept the null. Thank you very much. Thank you very much. Thank you very much. Okay, very good. Rather than accepting, we say reject the null hypothesis or fail to reject. We never say accept. Please note down this, something important. We never ever say accept. Why? Because our theory is dynamic. What was relevant 20 years back may not be relevant today, but may be relevant after another 20 years down the line. So in social science research, we are not sure 100% that this phenomena is like this. Because of different dynamic, different condition, it change over the period of time. So instead of saying accept, we say reject or fail to reject. So in our case, it would be fail to reject. So thank you very much. So that means there is no significant difference among a student as far as their marks in concern first and second year. Very good. Thank you very much. Great. And the third type is independent t-test. If you see on average, assumptions are same. In this case, the sample would be independent. Section A and section B. So here, instead of section, I have taken local student and commuting student. Both are different. Both are independent to each other, right? And I want to see, is there any significant difference between the percentage of marks scored by local and commuting student? And what would be null? No difference. There is no difference between the percentage of marks scored by local student and commuting student. Okay. Now, please, I'm going a bit fast now. Here, analyze. This is the command. And let me see what is the result. What is the result? This is, okay, this is the result. This is the significance is 0.902. Okay. So they are not significantly different. So three types of t-test we have discussed. Three types of t-test. Three types of t-test. Any doubt up to this? Tell me. And this is your chi-square test, which we already have discussed. We can take example of association between gender and location. Very nice. Same data, student data, their gender and location. Is gender having any association with location? Because both are categorical variable. Right? Any doubt, anyone? Any doubt up to this? Any doubt? Tell me. So a lot of things, just we are refreshing the concept. If you have any doubt, let me come to you. We have covered t-test. What is the purpose? What is the assumption? What is the concept that we have covered? And I have shown you chi-square also. Yes. Any doubt up to this? Tell me. Any question you have in your mind? I ask you one thing before I go further. In T, how many dependent variable I had? how many independent variable I have taken in t-test? Tell me, write in chat box. How many dependent variable I have selected in my t-test? 2, 3, or 1? In case of Thar, what was the dependent variable? Mileage, right? In case of this student, what was the dependent variable? Anyone? What were we checking? We were checking against marks, right? Or the score, right? So basic in Thar, it was mileage, one dependent variable. And how many independent variable? So in case of our student, it was marks of the student was dependent. And what about independent variable? How many independent variable? Score, right? Score is dependent. Thank you. And how many independent? How many independent variables? Maximum? In t-test, how many independent variable I have taken? I have taken before and after. I have taken first year and second year, right? So I have taken max 2 independent variable, right? That is the factor actually. That is the factor. Class, which one? Which class? Section A or section B? 2. Can I go beyond that? Okay, we had an example of faculty. Can I take faculty as an independent, right? And marks as a dependent? Tell me, yes or no? Faculty is categorical, right? Section A and section B is categorical. Independent data. Tell me, can I take this faculty and conduct a t-test? Faculty is also categorical 1, 2, 3. And what about commuting, local and commuters, something like that? So there also we can use, we have seen that commuters, local and commuters, their percentage marks, right? Their score. Is there any difference? So 2 we have taken. Can I take faculty as an independent and dependent score? Tell me in your chat box, yes or no. Quick response, everybody. Please give response. Yes. Anyone else? Please give response. Everybody, please give response. Just Sankita ji has given response. Now pay attention, everybody. Please pay attention. Conceptually, I am explaining this. Maximum 2 factors we can use in t-test. Male, female, before and after, section A and section B. But in case of a faculty, instead of 2, we had 3. When we go beyond 2, what happens? Tell me. You can't use t-test, my dear friends. Then extension of t-test is known as, anyone guess? And now you know the assumption, you know the basic concept. ANOVA. Thank you very much, Ankita. Thank you very much, Rashidi. Thank you very much. Yeah, thank you. So nice of you. Great. Now my question arises, why not 3? When we say 3, factors we enter into ANOVA. Why not 3 in t-test? Where is the problem? What is the problem? Now, I hope you are understanding the concept, what I'm talking to, what I want to discuss with you. You are able to understand. Please pay attention, everybody. The problem comes with significance level, and our significance level is 0.05. 0.05 work when we have maximum 2 factors. But when we comes to 3 factor, it get inflated, right? If it get inflated, what would be the problem? The risk would be high, and we don't want to take a risk. Risk of what? Risk of by chance, risk of failure, right? So this is the problem, that please pay attention. Dependent variable is 1 in t-test and 2 is the maximum factors. But when we go for 3 factors, for example, gender, male and female, if I take transgender, then I can't use t-test, I will go for ANOVA, and it would be a one-way ANOVA. It would be a one-way ANOVA. What would be a two-way ANOVA? What would be two-way ANOVA? Beside faculty, if I take gender and gender has 3, so that would be male, female and transgender. 2. If I take another categorical variable, 3-way ANOVA. So I hope you understand what I'm talking about. Please write yes in your chat box if you understand till now our discussion. Please go ahead, everybody. Write yes in your chat box. We have understood chi-square. The description I had discussed with you, I have given a command on SPSS. When you can run it, I will give you data also. You can practice. If you have any query, you can come to me and I can explain it on SPSS. But I will give you another tool where you can perform this. That right? Right? Yes, Dr.
Yes,
Sakshi,
Dr. Sakshi,
you have unmuted your
you have
mic. Tell me.
unmuted your.
Okay, thank you. No problem. Okay. Okay, great. So we have understood chi-square association, significance differences we have seen. Let us see few more things. And if I can cover regression. So here is the ANOVA. Here is the ANOVA. This is actually ANOVA. It looked like that we are comparing mean. Rather, actually we are not comparing mean. We are comparing the variance in this. So does the location of factory affect product quality? Location. And what is the dependent variable? Product quality. And location. How many location we have? So these are the assumption. Null hypothesis and alternative hypothesis. Right? Pay attention. Alternative so that at least one group mean is different from the other. So how many we have? 3 actually. Right? Earlier in t-test we have only 2. So this is basically ANOVA. I'm not going to discuss in detail. I hope you got the basic concept of ANOVA, right? So here the assumption of one-way ANOVA. I will share these slides, don't worry. You can go through this, right? So there is a difference in sales based on different education. Suppose you have primary education, secondary and higher education, right? Dependent variable sales and education has 3 factors, right? Everybody. And here, so this is which data? Data 4. I will give you this data 4 and you can perform this. And what is the command in SPSS procedure? One way with postdoc analysis, you can perform them, right? And here also I have given you more information. Why I'm going in hurry? Because I want to cover one more concept with you. And that is, just give me 1 minute. Let me find out that for you. Okay, fine. This I wanted to share with you. one more thing, because your hypothesis will be cover one more ingredient, and that is your linear regression, my dear friend. That is your linear regression. So we have covered association, significant difference, but we haven't covered the relationship and impact. We haven't covered the relationship and impact regression kind of hypothesis. I'm sorry, I'm a bit hurry, right? Because I wanted to cover this basic concept also with you. Uh, I hope this is visible to all. And let me make it big. Hmm? Generally, what we do, I hope you understand the relationship between two or more than two variable. How does house price, right? Uh, or weight of someone, height of someone, stock portfolio, these all are numerical value. Hmm? And you want to predict what would be the house price, right? If it is in the city, urban area, rural area, right? On the basis of area, what would the house price? How many stories it has on the basis of that house price, right? So you want to predict a continuous variable, right? Which may be impacted by different independent variable, right? So this is actually a linear regression. This is actually a linear. So what about house area and house price? What is general perception? House price would be high when house area is high, right? House area is large, house price would be high. This is a general perception. So how do I know this? So what I did, I collected this dot, I collected this individual data from person, and then I asked, what is your house area? This is the house area. What is the price of the house? This is the price of the house. And I see there is a kind of a relationship between house price. Now the problem here is, can I predict at 170 house area, what would be the price? Can I predict that? Hmm? Accurately, can I predict what would be the price of a house if house area is 180 or 125, 85? Hmm? So we can use this regression to find out this, right? To find out this kind of a relationship or an impact. So here you see, how much would this new house cost if we just know that it has an area of 122 square meter? How do I know that? Accurately, can I predict that? Can I predict that this cost or price of a house? Ladies and gentlemen, one idea is to build a line that would represent the relationship between the area and the price of the house, and then classify the new point according to the line, right? Now the problem here is, can I make this line? Can I draw this line which actually show the relationship between area and the price? The problem would be, price are, these dotted are away from the line, and we call them errors or residuals. Please note down, we call them errors or residuals. How exactly do we find this best line? This is the problem. I can draw 3, 4, 5 different lines covering all possible dots, but still you will be not able to cover. So these errors or residuals would be there. You can draw tons of lines. You can draw here, right? But our line would be, a line can be characterized by an equation, and that equation is y is equal to b plus mx, right? A plus bx, something like that you can write. That's not a problem. Okay, so here you see this. I hope you all understand. right? This I'm not going to define further. Intersect, coefficient, you all aware of this. You all have learned this. Just skip it quickly. So from ANOVA, right? ANOVA is the first step of entering into modeling. And this is a modeling where we want to predict house price, right? We want to see the house price. So here we go. We want to predict house price on the basis of what? Square meter. We want to predict house price on the basis of square meter. For our example, where we want to predict the house price of a house with 121 square meter, we know the following. House price, this is our objective, find what is the house price, right? Beta, that we need to calculate. Square meter, that we know, right? Okay. How exactly do we learn this bias beta? How do we learn that? So please pay attention. I mean, with the help of permutation combination, we can do that. With the help of permutation and combination, we can do that. For example, first idea, try random value. Try random value. Let us try A 10,000 and beta B1 1,000, right? And then we see, okay, price is 10,000. Where is 10,000? And then 1,000, and we get output 1,32,000. Is it right? Is it the right way? Is it the best fit? And when you draw this 1,32,000, it is far below the line, right? Another idea, we can change the beta, right? And we can say that, okay, earlier it was 1,000, now it's a 1,500. So it's on the basis of some trial error method, right? 1,500. So it has gone up. Can we do like this? Oh, it's much, much, much better. Third idea. So we have three ideas. Try more random values. We can try more values, right? So through this, that seems a good fit. Here, this seems a good fit. During this trial and error approach, we also develop an equation. And where is the equation? Here you can see 10,000 plus 2,000 into x. Y is equal to 10,000 plus 2,000 into x. Okay. So here you see it's gonna be house price is equal to 10,000 plus 2,000 square meter. We have, so this is linear equation we have generated. Now the problem here is this. We want to construct that line pass through most of the point, right? Mathematically, we want to get line that minimize between each point and the potential line, generally called least square method, right? This line is actually what happens if when you draw a line, generally some would be above and some would be below the line. If you sum them up, what will happen? Answer would be 0. So what we do generally, we square the values and then what happens? That's why we call it least square method. Okay. So here you see we are, coming close to line. The line is better as difference between each point and the line is lower. Okay, this is the perfect line, right? But still, this line seems really good as the error between each point and the line is really low. So we want to, so I'm showing you pictorial kind of representation and with the data, what actually happens behind the line. You can easily calculate it. I'm telling you with R, you need to give just one command and you will have the answer. But what is going on? How do we draw it? What should be the line? What is the use of line? What is this red point? These are error, these are residuals, right? So in our model, which is based on regression, what we are doing actually, right? So I just skip it. Okay. Now here you see everybody. Y square difference so that the error don't cancel out each other. If I go more above and below, this will cancel to each other. So what we do, we go for square of that. Similar like this, each of our different line will produce different cost functions. So another example of cost function, cost function. So first was, I hope you remember, we had an example of house price, then the cost function. So this is basically, I'm not going into R right now, right? So you got some idea of this. You get some kind of idea of this, that what is the regression. Now let me show you the AI. Please pay attention, everybody. AI is, this is Julius AI. Have you used it? Please tell me in your chat box, yes or no. Did you use it ever, Julius AI? Write in your chat box, everybody. Tell me. No, no. Okay. 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 Fine. 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 I have paid version, but is in another laptop. But the problem with that laptop is I'm not able to open this platform, right? Let me see if I can try it here right now. Okay. Continue with email. Oh my God, it will ask for a email. Let me see if I can. Oh, restart. This is the code. I request you, everybody, please open this AI. Please open this AI, Julius AI. Oh,
Thank you so much. Thank you.
okay, please
हमारी
pay
क्लास
attention.
हमारे वहाँ के बच्चे कई बच्चा आदित्य
Oh,
विश्वास
okay, okay. So this is the dashboard of Julius AI, my dear friends. What would be use of Julius? It can perform any analytics. And here you see 15 messages left. That means 15 syntax or 15 command you can use right now, right? Generally what we do, this is attachment. So add file, upload file. Let me upload for you. Which file? Let me check. Student data 1. Okay. So this is a very advanced kind of AI. Will not only analyze your data, will give you analytical result, but also will suggest you, right? Will suggest you what you can do with this type of data, right? So now my file is here, and right side you can see, my dear friend, I haven't told this AI anything. Now I have just uploaded a file, and here you see the file contains student data for a single class section with fields like student ID, section, gender. Now you know your data. You know your variable, right? And score, faculty, and year one, year two percentage, house percent, oh sorry, hours spent reading, and absence incidence. It can be used to explore relationship between academic performance. No, I haven't told anything to this. This is giving me advice what I can do, right? It is giving me a kind of advice. Explore relationship between academic performance and percentage, and factor like study time or attendance, as well as compare by gender, location, and faculty. You can right click on the column preview or plot additional detail. So now you see, this is the beauty of this. Are you with me, everybody? Whatever I have done with you today, chi-square, for chi-square, which now you know which variable you can use. So tell this that use chi-square test and these two, take these two variable and it will do like this quick. Take a t-test. Okay. For example, pair t-test for percentage first year and let me see, and percentage second year perform pair t-test. Let us see what result we get. Oh, it is asking for money. See here, if you know the Python, it will run Python. It run on R also, right? Here you have option, this option, change code language. You can change for Pascal, Python, and you can change for R programming. So you don't need to design and make a syntax. It will give you a syntax, right? It will give you a syntax. You got to answer, everybody. Pair t-test. I ran a pair t-test comparing percentage and the result. You got a static value, p-value, right? Degree of freedom, you got that, and conclusion you got with p-value about 0.51, which is much larger than the common significance. We have failed to reject the null hypothesis. Therefore, there is no evidence of significant difference between mean percentage of first year and second year. Same answer which we had. Are you with me? Whatever we have learned in last 2 or 3 classes, you can perform here like this. And now it will give you some suggestion also. It is saying what is the difference between percentage and mass. You can calculate how would result change, outlier removed, right? You can remove outlier also. As a student version, it costs you 500 rupees per month. And it can help you to perform all advanced kind of analytics, my dear friend. Now, you know basics of data, descriptive statistics, you know categorical variable, you know continuous variable, you know chi-square, you know t-test, you know regression, all you can perform, but what you need to do, you must know what you are going to do, and it will give you answer. And here you can change with R also. If you want to learn R syntax, it will design and develop R syntax, and then you can copy and paste in R. But here you're gonna get all possible answers, right, my dear friends? So this was something from my side. I thought I should share with you. I'm sorry I'm completing it today a bit early because I have another lecture at 4 o'clock. I'm sorry for that, but we have learned a lot of things, basic concepts. I wish we would have more time. We would have discussed more things, but now we have learned some software, some AI for review of literature, and one unique advance for all possible analytics and analysis is Julius AI. So I hope you all will be subscribing, mention as a student, and it will cost you 500. Just give a file. It will give you insight. You can write insight and it will tell you what it can perform for you. That's the beauty of this. Even you can run a SAM also. I run a SAM, structure equation modeling, right? So thank you very much. Any query you have, you can ask. Otherwise, thank you very much. Goodbye. Take care. Thank you.
Thank you so very much, sir.
Thank you, ma'am.
I think we can have sessions in future too, because it was quite informative too.
Sure. Thank you very much.
Okay, thank you.